All right, so we have been working on how to write names and formulas of ionic compounds this past week. We're going to now learn how to write names and formulas of molecular compounds. Molecular compounds are also known as covalent compounds. Okay. So our covalent compounds and ionic compounds are going to look, ionic or crystalline in structure, covalent, crystalline solids, covalent could be solids, liquids, or gases at room temperature. Covalent compounds tend to be softer, have lower melting points, lower boiling points than ionic compounds do. They also react differently because covalent compounds are going to share electrons instead of transferring them, which means that there are no ions, which, lucky for us, means that we don't have to worry about looking up charges. So the rules for naming and writing formulas for covalent compounds is different. So molecular, also known as covalent compounds, are identified by having a nonmetal and a nonmetal. Okay? So you'll look at the chemical formula and see if it's a nonmetal and nonmetal, then you're using covalent naming and formula writing rules. If it's a metal and a nonmetal, then you would use ionic naming and formula writing rules. Okay, so we're going to learn today how to write names and formulas of these covalent compounds. So the first rule is that the first nonmetal that's written is usually the least electronegative. So the one that's furthest to the left on the periodic table. Then you're going to look at the name of the first element in the compound, and you're going to write that name, and you're going to put a prefix on the front. That prefix is the number that represents the number of atoms of that element. Okay? So in the first element, you're going to write the prefix that represents the number of atoms and then just the name of the nonmetal. The only exception is if there's only one of them. So you're not going to use mono if there's only one. Okay. So if there's only one of the first element, one atom of the first element, you will just write the name and that's it. Then for the second nonmetal, you're going to put the prefix on the front for the number of atoms of that second nonmetal, and you're going to change the ending to "ide" like we've done before. And combine the two, and that is the name of the covalent compound. So let's look at some examples down here on page 10. So our first chemical formula is N2F5. Nitrogen and fluorine are both nonmetals, which tells me I'm using covalent, or also known as molecular, naming and formula writing rules. In this case, we have nitrogen as our first element, and there are two of them. So the prefix for two is di. So I'm going to write di-nitrogen. And then there are 5 fluorines, and so I'll write penta for 5. And then I'll take fluorine and change the ending to ide, like we've done before. That's a U. Okay, so it's dinitrogen pentafluoride. So if I see prefixes, that tells me that it must be a covalent compound. All right, our second example has carbon and oxygen, which is a nonmetal and a nonmetal, which means it's molecular. There's only one carbon, so no mono. You're going to write just carbon. And then I see that there are 2 oxygens, so I'm going to write di, and then oxygen becomes oxide. Our next one, we have lithium and nitrogen. Lithium is a metal and nitrogen is a nonmetal, which tells me that this compound is ionic. So now I'm using my ionic naming rules. I'm going to write the name of lithium. Lithium's in group 1, so it is not a stock system metal, so no Roman numeral. And then I'm going to write nitrogen, but I'm going to change the ending to ide. Okay. Our next one is nitrogen and phosphorus. So this one is molecular, also known as covalent. I have trinitrogen because there's 3 of them. And then there are 6 phosphoruses. So I'm going to write hexa and then phosphide. Okay. And then our last one's a little tricky because we have boron. Boron kind of sits right on that fence, and I can see that I have 3 bromines. So boron's charge is +3. Bromine's -1. So I have 3 negatives and 3 positives. So it's very possible that this is an ionic compound, okay? If I had like B2Br3, then that would tell me that it has to be molecular because the charges wouldn't add up. So in this case, because bromine, there are 3 of them, I have 3 negative charges. Boron, when it forms a charge, is +3. I can use ionic naming rules for this. So this is going to be boron, bromide. Okay. So if you have one that maybe with a metalloid in it, you can look to see if they do the charges add up or not. And if they don't add up, then you can definitely say you need to use the molecular naming and formula writing rules. All right, let's write some formulas. So this is pretty easy because the prefixes tell you what your subscript needs to be. So I have carbon, there's no prefix, so it's just 1. Okay. Monoxide, I have this mono. You'll notice in names with oxygen, if I have mono, I wouldn't write mono and then oxide after it. I drop the O on mono and then write oxide. We'll do the same thing with deca and oxygen. So any of these prefixes that end in A or O before oxygen, you'll drop the A and the O. Okay. So this will be carbon, and then there's only 1 oxygen, just carbon monoxide. Dinitrogen tells me it's N2. Oops. And then hexabromide, Br6. Okay. So again, I'll with oxygen, it's a little tricky when you have prefixes that end in A or O. So if I had like deca for 10 and I needed 10 oxygens, I would drop the A on deca and then write oxide. So it becomes dec oxide. Okay. We wouldn't have monoxide, MONOOXIDE. We would have monoxide. So drop the A and the O before oxygen. Okay. So your practice is going to be at the bottom of page 10. There are 10 problems to have completed for class on Monday. And that is it.